Hello everyone, welcome to today's lecture on resolution, refutation and reasoning in artificial intelligence. I am Professor Monica Raghuvanshi and in this session we will learn how AI systems use logic to make decisions and prove statements just like humans use reasoning to solve problems. Let's start with resolution. Resolution is a rule of inference used in automated reasoning and theorem proving. It helps combine two logical statements to make a conclusion by removing opposite parts. Think of it like this. If we know it's either raining or sunny, then it will be represented as P union Q or will be represented as union as a sign that you can see in the slides. It's not sunny or it's cloudy. Not will be represented as the negation sign. So negation Q, union R. Then applying resolution, we can conclude P union R. And union, we can also call it as a conjunction. We eliminated the contradictory part Q and negation Q and got a new statement. Resolution rule in propositional logic. The general form is simple. If we have A union B and negation B union C, then the resolvent is A union C. We just remove B and negation B because they cancel each other out. This is the foundation of reasoning in logic-based system. Let's look at an example. We have a knowledge base P union Q, negation Q, union R, negation R. We want to prove P. So step 1 will be, we will combine second step and third step. Negation Q, union R and negation R. That will gives negation Q. R and negation R will be cancelled out. Combining 1 and 2. P union Q and negation Q. P, Q and negation Q will be cancelled out. It will give P. Here P is proved using resolution. Next, refutation. Refutation is a proof by contradiction method. We assume the opposite of what we want to prove and then use resolution to reach a contradiction. If a contradiction occurs, it means our assumption was wrong. So the original statement is true. Example of refutation. Let's prove P is true form. So step 1 P union Q, step 2 negation Q. Now let's prove it. Assume negation of goal, that is negation P. So our knowledge base becomes P union Q, negation P. Now we will apply resolution. From step 1 and step 3 we will get Q because P and negation P will be cancelled out. From second step and fourth step Q and negation Q. So Q and negation Q will be cancelled out and contradiction will be proved because empty clause we will get the empty clause. Therefore P is true by refutation. Now resolution. Let's move beyond simple statements to predicate logic. Convert statements into clausal normal form using formula like A implies B is equals to negation A union B. We have to standardize the variables, negate these statements that we need to prove. We have to apply unification and resolution repeatedly as we have done in the examples. If you reach an empty clause, then the proof is complete. Let's move on to the next example of predicate logic. Given for all x, man of x, implication modal of x. Next step, man Socrates, and we have to prove mortal Socrates. So step 1 will be, as we have read in the year, step 1 will be converted to CNF. So negation man x union modal of x. Man Step 2 will remain same, man Socrates. Step 3 that we need to prove, we have to assume that as a negation portal of mortal Socrates. Now step 2, we have to apply unification and resolution. So from step 1 and step 2, we will get mortal Socrates. So we will combine with negation mortal Socrates. So mortal Socrates and negation mortal Socrates will be cancelled out and we will get the contradiction. So Socrates is mortal, that will be proved by refutation. Next, what's the difference between resolution and refutation? Let's summarize. Resolution combines clauses to derive new information, and refutation assumes the opposite and looks for contradiction. As you can see in the diagrams, together they form the core logic based reasoning in artificial intelligence, especially in theorem proving. Next, move on to different reasoning types. First is monotonic reasoning and second is non-monotonic reasoning. Let's start with monotonic reasoning. In monotonic reasoning, when we add new knowledge, it does not change. The old conclusion will remain same. Once something is true, it stays true. Just for example, all birds can fly. Tweety is a bird, so Tweety can fly. Even if we add new facts, this conclusion remains the same. This is how predicate logic works. It's monotonic. Next, non-monotonic reasoning. But in the real world, things are not always like that. In monotonic reasoning, conclusion remains same. But in non-monotonic reasoning, if we will add new facts, then it will change previous conclusions. Just for example, initially birds can fly, Tweety can fly. But new fact, if we add Tweety is a penguin. Now we must update our belief that Tweety cannot fly. This type of reasoning reflects real-world uncertainty and is used in default reasoning, expert systems, and common sense reasoning. Let's conclude. To summarize, resolution combines statements logically, refutation proves statements by contradiction. Monotonic reasoning conclusions never change, but in non-monotonic reasoning, new facts can change conclusion. I hope it's clear to you all. Thank you.